Hello everyone. On this video we will be looking at the laws of sine and cosine for both angle side angle, angle angle side, and side side angle triangles. Okay, so first we want to look at the laws of sine. Okay, and either one of those can be used. You have side A over sine of A equals side B over sine of B is equal to side C over sine of angle C. Or you can just flip those around and have sine of A over side A equals sine of B over side B equals sine of C over side C. Okay. Now, a little thing you want to remember is that the largest side of a triangle is always opposite the largest angle. And that comes in handy. All right. So if you're still writing, feel free to press pause, but we're going to go ahead and move on to the next page and show you the 4 possible outcomes when solving for your triangles. Okay. Now, when given certain bits of information and you try to solve it, you always have the option of having no triangle solution. Or your outcome could be a right triangle. And then you have the 2 triangle possibilities. So let's say you're given, just on this one, the length of side B and angle A. Now, if you don't know the length of this side, when you solve for angle B, that can either give you an acute angle or possibly an obtuse angle, especially if you know the length of side A and it can just swing from this way to this way. Okay, so in some cases, you will have to solve for both possibilities of B and then just see where it goes from there. Okay, and pick the possibility that fits. Okay, and I'll show you how to do that. Okay, and then we have the 4th possibility, which is one triangle. Okay, that's the one when given a certain amount of information, only one triangle will make that true. All right, so if you are still writing, of course, feel free to press pause and finish up. But we're going to go ahead and move on to our first example. Okay, so for the following triangle, solve for side B and side C. Okay, so you see our triangle here. You have angle C is 71 degrees. Angle B is 60 degrees. We don't have angle A. And I'm going to show you how to read the triangle. If you have angle A here, directly opposite of it is your side A. And if you have angle B here, directly opposite of it is your side B. Same thing with angle C. If you have angle C here, directly opposite is your side C. Now, normally they'd use like uppercase letters for your angles and lowercase letters for your sides, but it varies, so don't get too hung up on the variables, but this is the main idea here. Okay, so first of all, using the law of sines, well, first let's solve for angle A, since that would be the easiest. Then we can use the law of sines. Okay, so we know that angle A plus angle B plus angle C has to equal 180 degrees. Okay, for any triangle, you add all the angles together, it's always going to equal 180 degrees. And we're doing this first because we're given 2 of the angles. So we might as well solve for the 3rd, angle A. So if we subtract angle B and angle C from both sides, we know that angle A is going to equal 180 degrees minus angle B minus angle C. Okay, so that means that angle A is going to equal 180 degrees minus 60 degrees minus 71 degrees. Or that angle A is equal to 49 degrees. Okay, so why did we need angle A? Well, we needed angle A to use the law of sines. We didn't specifically need angle A, but considering which sides we're solving for, I'll show you why we needed angle A. Okay, so remember your laws of sine. A over sine of angle A equals side B over sine of angle B equals side C over sine of angle C. Okay, now remember, you can just use two of these. You can use A and B, or A and C, or B and C. You can use any two of them to solve for a missing side or angle. The only thing is you have to know at least three of the values. So you couldn't solve for, excuse me, for side B if you're using these two without knowing angle B, angle A, and side A. So that's why we needed angle A, because you have to know at least three out of the four missing values. So if you have A over sine of A equals B over sine of B. Okay, so if we plug in the three values that we know, we have side A, which is 18, over sine of A, which we just solved, so sine of 49 degrees, equals side B, which is unknown, over sine of B, which is sine of 60 degrees. So if we multiply both sides by sine of 60 degrees, we know that B would equal 18 over sine of 49 degrees times sine of 60 degrees. Okay, plug this into your calculator, and you will see that side B is approximately equal to 20.7. Okay, so now we can solve for side C. Okay, now remember, you can't just use the Pythagorean theorem because this isn't a right triangle. So to solve for side C, let's say we use A over sine of A equals C over sine of C. And again, we know at least three of these, so we can solve for C. Okay, so sine of A, well, side A is 18. And sine of angle A is sine of 49 degrees equals side C, which is unknown, over sine of angle C, which is 71 degrees. Excuse me. Okay, so we multiply both sides by sine of 71 degrees. We have C is equal to 18 over sine of 49 degrees times sine of 71 degrees. Okay, so plug this into your calculator and you should end up with C being approximately equal to 22.6. Excuse me. All right. So if you're still writing, feel free to press pause. We're going to go ahead and move on to our next example. Okay, so let's say the unknown triangle ABC has angle A equals 60 degrees, and sides A equals 12, and side C equals 19. Let's say if we want to solve for angle C. Okay, so the first thing I always do when they don't give you a triangle is I sketch the triangle. And again, this is optional. To me, it just helps visualize it. Okay, so it's just you're just sketching the possible triangle. Okay, remember you have no idea what the triangle looks like, so you're sketching what it possibly could look like. Okay, so if we sketched it, so let's say we go ahead and sketch some random triangle. Let's say this is angle A, angle B, and angle C. So this is angle A, that makes this side A. If this is angle B, that makes this opposite side B. And this is angle C, so that makes this opposite angle C. Okay, so we know that angle C equals 19. Angle A is equal to 12. Well, side A is equal to 12, and angle A is 60 degrees. Okay, so using our law of sines, you have A over sine of A equals B over sine of B equals C over sine of angle C. Okay, so using the information that we have, we'll use these two. So we have side C, side A, and angle A. We can solve for angle C. Okay, so you have A over sine of angle A equals C over sine of angle C. So if we plug all these in, we have A, side A, which is 12, over sine of A, so that's sine of 60, equals side C, which is 19, over sine of C, where our angle C is unknown. Excuse me. Okay, so now we can just go ahead and cross multiply. Okay, so we have 12 times sine of C equals 19 times sine of 60 degrees. Okay, so if we divide both sides by 12, we have sine of C is equal to 19 times sine of 60 degrees divided by 12. Okay, so if we plug this into our calculator, that gives us sine of C is approximately equal to 1.371. Okay, now actually we could just go ahead and stop right there. Okay, so we can see here that no valid solution will exist, not for this triangle. Okay, so no valid solution exists since sine of C would have to oscillate between -1 and 1. Okay, so remember your graph of sine, it always bounces between -1 and 1. So unless it's being multiplied by something, there's no value that you can plug in, or no angle you can plug in for C that would give you a value larger than 1 or less than -1. Okay, so no triangle would actually satisfy the values given above. All right. So, again, if you are still writing, feel free to press pause and finish up. But we're going to go ahead and move on to our next example. Let me move this down. Here we go. Okay, so for triangle ABC, where C is equal to 46 degrees, side C is equal to 20, and side A is equal to 22, solve for angle A. Okay, so with this one, there are two possibilities because this is a side-side angle triangle. And I'll show you what I mean by that. Okay, let me get my... Okay, so if you have... Let's draw the first possibility, and I'll show you why they are possibilities. Okay, so we know the angle C is 46 degrees. Let's say if we make this angle B, and this is angle A, which is what we're solving for. Remember, angle C is opposite, or side C is opposite angle C, which is 20, and side A is opposite angle A, so this is 22. Okay, now this gives the possibility that A is an acute angle. Okay. Okay, so it could be possible it's less than 90 degrees. But let's say that we still have angle C equal 46 degrees. Let me shorten that a little bit. That's a little bit rough looking. Let me try and draw it a little straighter. There we go. Okay, so let's say this is still 46 degrees. That's your angle C. And this is your angle B. Okay, and this is still a length of 22. Now, it's possible that C could still be 20, a length of 20. But what if it swings the other way? What if it swings this way? Okay. By us not knowing the length of side B, we have no idea which one of these triangles would be actually true. Okay, so angle A could possibly be obtuse. Okay, so what we do is we just go ahead and try both and see which one. Well, actually, this one just wants both possibilities. Okay, later on we'll solve and show you how to see which one is which. Okay, so using the law of sines, we have A over sine of A is equal to C over sine of C. All right, so again, we go ahead and we plug in all of our known values. So A is a length of 22, and sine of A is unknown, equals C, which is 20, over sine of C, or sine of 46 degrees. And again, we go ahead and cross multiply. Okay, so we know that sine A times 20, or 20 times sine of A, is equal to 22 times sine of 46 degrees. Okay, so if we divide both sides by 20, we have sine of A is equal to 22 times sine of 46 degrees divided by 20. Okay, so if we plug this into our calculator, we have sine of A is equal to about 0.7913. Okay, so if we apply sine inverse to both sides, we have sine inverse of sine. The sine inverse and sine would cancel out, so that'll leave us with just A is equal to sine inverse of 0.7913. So really A would be approximately equal to 52.3 degrees. Okay, so that's its acute possibility. Okay, what's the other possibility? Well, if you notice here, sine is positive. So in a unit circle, your sine is equal to y. Okay, so the only two quadrants where your sine is positive is quadrant 1, which is your acute angle, or quadrant 2, which would give you your obtuse angle. Okay, so for quadrant 2, to find your other angle, we'll call that angle 2, and we'll say this is angle 1, just to give it a name. Okay, so let's say we'll call that angle 1. Okay, so to find angle 2, we have 180 degrees minus the 52.3, which is 127.7 degrees. Okay, and this is your obtuse possibility. Okay, now you can always check these, because both, if you add these together and they're less than 180 degrees, then you know it's both are valid possibilities. All right, so again, if you're still writing, feel free to press pause and finish up, but we're going to go ahead and move on to our next page, which covers laws of cosine. Okay, so if you have a squared is equal to b squared plus c squared minus 2bc times cosine A, or if you want to solve for cosine A, you have cosine of A equals b squared plus c squared minus a squared all over 2bc. You have b squared is equal to a squared plus c squared minus 2ac times cosine B, or if you solve this for cosine of B, is equal to a squared plus c squared minus b squared over 2ac. Now, if you want to solve for side C, you have c squared equals a squared plus b squared minus 2ab times cosine of angle C. Or if you want to solve for this cosine of angle C, that's equal to a squared plus b squared minus c squared over 2 times a times b. Okay, now these three on the right, you mainly use those if you're only given the sides of a triangle. Okay, so if you're only given the sides and you're not given any of the angles, you can use this to solve for one of the angles. Okay, so that's mainly where these 3 on the right come in handy. All right, so if you're still writing, of course, feel free to press pause and get it all down. But we're going to go ahead and move on to our last example. Okay, so let's say we want to find the missing length and angles of triangle A, B, and C, given that angle B is equal to 34 degrees, side A is 15, and side C has a length of 21. Okay, and again, first thing you want to do, at least first thing I do, is sketch my possible triangle. Okay, so again, we have no idea what the triangle looks like, so this is just something to help us visualize. Okay, so let's take this A, angle B, and angle C. So that will make this side B, that will make this side A, and that will make this side C. Okay, so we know that angle B is 34 degrees, so we can make that 34 degrees. Side A is 15, so we're going to make that 15. And side C is 21, so we're going to make that 21. Okay, so let's say we want to solve for side B. And we know we're going to use the law of cosine. B squared is equal to A squared plus C squared minus 2 times A times C times cosine of angle B. So if we plug those in, we have B squared is equal to A squared, so that's 15 squared plus C squared plus 21 squared minus 2 times A times C times cosine of B. Okay, so all we did was plug in the values we had right there. Okay, so we plug all that into our calculator. We get B squared is approximately equal to 143.7036, approximately. So if we square root both sides, that means B is approximately equal to 11.9878. Okay, so we solve for side B. Okay, so now that we have side B, and you're probably looking at it thinking, well, couldn't we use law of sines to solve for angle C since we have side A, side C, and angle B? Well, you could, but you'd still need side B, because if you have angle A and angle B, then you would need at least side B to solve for angle C. Okay? And if you try to solve for angle A, you'd still need side C to solve for angle A, because you need side A, side C, and angle C. Remember, you need 3 out of the 4 missing values to use the law of sines. So we need angle B to do that. So this allowed us to now start using the law of sines, which is a little bit faster. Okay, so let's say we want to solve for angle A. Okay, so we have sine of A over side A equals sine of B over side B. Okay, so if we go ahead and plug in our values, we have sine of A over side A, which is 15, equals sine of B, so that's sine of 34 degrees over side B, which is 11.9878. Okay, so if we multiply both sides by 15, you have sine of A is equal to 15 times sine of 34 degrees over 11.9878. Okay, let me move this up just a little bit. Okay, so we plug all of that into our calculator. It gives us sine of A is about equal to 0.6997. Okay, so we see this value is between 1 and -1, so we know we can keep going. So if we apply sine inverse to both sides, we get A is equal to, approximately equal to, the sine inverse of 0.6997. And if we plug that into our calculator, that means angle A is about equal to 44.4 degrees. Maybe. Okay? Because remember, we don't know whether or not A is acute or obtuse, because we don't know well, we can figure it out because we figured out side B, but I'm going to explain to you why you can kind of figure it out. Okay? Now, angle A could be 180 degrees minus 44.4 degrees, which is 135.6 degrees. Again, could be this one. Okay, well, how do we know which one it is? Look at your triangle. Remember that very first thing I told you on the first page. The largest angle is always opposite the largest side. Okay, so we see here that B is 11.9878. Okay, so out of all three sides, C is your largest side. We can see that just from here. We can see that it's bigger than 15 and bigger than 11.9878. So that means C would have to be your largest angle. A couldn't be your largest angle because side A is not your largest side. So that means 44.4 is the correct one. Okay. So since, let me move this up a little bit. Side A is not the longest side, then angle A can't be the largest angle. Okay, so that means that A being equal to approximately 44.4 degrees is correct. Okay, so we still have to solve for angle C. So if you are still writing this, of course, feel free to press pause and finish up. We're going to go ahead and continue this on the next page, solving for angle C. There we go. Okay. So for angle C, again, we know that angle A plus angle B plus angle C is 180 degrees. So that means angle C would have to equal 180 degrees minus angle A minus angle B. Okay, that means it would have to be 180 degrees minus 44.4 degrees minus 34 degrees. So that means that angle C is equal to 101.6 degrees. All right. So hopefully this made a little bit of sense to you, and I will see you on the next video.